Hey boys and girls, Mr. D. In this video we're going to take a look at absolute value equations, absolute value inequalities. Really if you're able to solve regular equations, regular inequalities for a variable, doing the absolute values, really no more challenging than those. It's just going to provide an additional couple steps. What we'll actually end up doing is we're creating two equations for one. Right? So it'll be a little more work. However, certainly very capable of doing it. Everybody's very capable of doing it because you guys have all been solving equations and inequalities for variables. So that part won't get any more challenging. So let's take a look here at the first example to see what I mean. So if we take this example, we have the absolute value of 3x minus 6 minus 5 equals 7. So the first thing we've got to do here is we need to get the absolute value alone on one side. So in order to do so, we'll add 5 here. Okay, add 5 to both sides. Okay, and so we got 12 over here. And on the left side, we've got the absolute value of 3x minus 6. Okay, so we've got the absolute value all by itself here, just like the say let's do. Right, now, the next step is we want to get rid of the absolute value. In order to do so, we're going to make two equations. So we'll get rid of the absolute value. We'll make two equations here. So the first one, we just write it as it is. So without the absolute value, 3x minus 6 equals 12. Okay. Then the second one, what we'll do is we're going to change the sign of the right side of the equation. So 3x minus 6 equals this 12. We're going to make that into a negative 12. So we've got two equations here to solve now. So what we'll do is we'll just solve these each for x. Here I go plus 6 to both sides. Right, and I've got 3x equals 18. We divide by 3. We know that x will equal 6. Okay. Let's try writing that again. X will equal. See, that does it again. Man, doesn't like my equal signs. Let's try it. Third time's a charm. X equals 6. There we go. Alright, take a look at this right side, the second equation we made. So again, it's two equations. Same process though. Add 6. The numbers will work out a little bit differently because we got this negative 12 as opposed to a positive 12. So on the left side we have 3x. On the right side, negative 12, positive 6, that gives us negative 6. We'll divide by the 3 we have here. X equals negative 2. And if you think about it, so there's two answers here, and if you plug them back in, look what you get. Let's start with the green one. 3 times negative 2 would give you negative 6. Negative 6 and negative 6, well, that's negative 12. When we take it out of the absolute value, it would be positive 12. 12 minus 5, that would give us 7. Do the 6 here. 6 times 3 would be 18. 18 minus 6 is 12. 12 minus 5, 7. So you see how they both work out. So the main thing here you got to remember is get the absolute value alone, and then you're making two equations. Notice, remember, we changed the sign of the 1, right? So this became negative 12. This one here is positive 12. Notice, this is how we're solving equations. This next example we're going to look at is an inequality. Very similar, slightly different. So here in our inequality, the first rule is basically the same. Still got to get the absolute value all alone on one side. So let's work for that. Okay, we go minus 3, minus 3. Now we got negative 6n in the absolute value is greater than 24. Alright, now that we've got our absolute value alone, again, here's where it is. We'll do pretty much the same thing, but slightly different because it's an inequality. Right, we have that. Here's our inequality sign, right? So what we're going to do is we're going to, again, create two equations. First one exactly how it is. Negative 6n greater than 24. Alright, second one, we're going to flip the sign and also change the sign that we have over here. So If you think about the equation, when we did the equation, we just had it as be negative 6n, then we'd have a negative 24. If it was an equation, we would put the equal sign here, but it's an inequality. So we're going to flip that. Okay? Now as we go ahead and solve, we'll be doing some more flipping if you look ahead here. We got to divide by negative 6. You guys all know that if we divide by a negative or multiply by a negative, we got to flip that sign. So 24 divided by negative 6, n is less than negative 4. Over on the second equation, same thing, divide by negative 6. Again, we're dividing both sides by a negative, so we got to flip that sign again. Negative divided by negative will be positive 4. So if I wanted to create a number line here, let's do this. Use that to separate them. So if I wanted to create a number line here to graph the solution, all right, let's take our 0 here. We have n is less than negative 4. So we know that's going to take us down to the left here. Open circle. Right, or all the way down here. We can go positive, right? N is greater than positive 4. And again, open circle, because it doesn't have the equal sign underneath it. So open circle, that's everything greater than 4. Again, if you think back to our previous lesson, would this be an AND inequality or an OR inequality? This is AND or OR. This is obviously an OR because you can't be bigger than 4 and less than negative 4. You could be one or the other, right? There's no numbers that exist over here that also exist down here. You're one or the other. Again, and it fits. Again, if you think about plugging in a number, look at here. 0, according to this, would not be a solution. And we know 0 is always easy to plug in. So look if we do a test plugging in 0. 6 times 0 would be 0. 0 plus 3 is 3. Is 3 bigger than 27? No. So it does not. 0 would not make a solution, and thus, if you look down our graph, we see that here. 0 is not colored in. If we did something like positive 10 or even 100, right? Think about 100. You'd have negative 600 here, but it would become positive 600 when you take it out of the absolute value. 600 plus 3, definitely going to be bigger than 27. Okay, so it works. Our checks work there. All right. Hopefully this is helpful. Again, absolute value equations, inequalities, really just means you have to create another equation. Again, we do opposite signs. Right? We change the sign when we make that new equation, and if it's an inequality, we flip the sign as well. Okay, so out of our two equations, we always have one as the original, whether it's an inequality or whether it's an equal sign. The first equation is always just the same, just get rid of the absolute value. The second one is where we change some things up. Hope this is helpful. See you guys in class.